Alright, so last time we did a little bit more with translations and rotations, and we're still sort of on that path, but now we're going to do something that's a pretty common operation that you need when you're making a game. Basically what it's going to be is it's a new script that will apply to our cube, and it will allow the cube to look at and follow a particular target. So let's go ahead and do that now, and we'll create a new JavaScript here. We'll call it follow. Bring it up. Alright, here we go. The first thing we need is a target to follow. We basically some transform that we're interested in. So we will do that. We'll call it toFollow, and it is of type transform. So in our update, we basically need to do two things. We need to make sure that the object that this script is going to be attached to is rotating towards its target, and then we also need it to move towards the target. So we're going to have a rotation, and we're going to have a translation in this particular script. The very first thing we need is actually a direction vector. And the process for getting a direction vector might be a little confusing at first, because it basically is a subtraction operation between two different vectors. Maybe the details aren't particularly important, but if you go online and look at subtracting vectors and kind of seeing visually what that does, it starts to make sense. But for now, we'll create a new variable and we'll call it direction. And we'll take the toFollow dot position, and we subtract excuse me, the current transform's position. There we go. Alright, so now we have a direction vector. The next thing we're going to need is an angle. And the angle is going to be important for when we tell the object that the script is attached to how much we need to rotate. So we know we're going to use the transform.rotate function. We don't necessarily know how many degrees we need to rotate to be looking towards the object. So we're going to create var angle, and we're going to let that, there's a special function on vector3 that we can call, which is nice. It's just called angle. And it gives us the angle between two vectors. And in this case, we want the angle between our direction vector and the vector of our current position. So we'll just type in transform.position, and that should give us the angle that we need. So now the next operations are pretty simple. We use a transform.rotate, and it needs a vector that we're going to rotate around. In this case, we'll just use vector3.up or the y-axis, and then it needs an angle. So we'll supply the angle that we have. We'll also multiply that by time.delta time and a speed. In this case, I'm going to go ahead and hard code the speed, but it's pretty much recommended that you go ahead and let's go ahead and just expose it right now. Rotation speed float, and we will give it a default of, I don't know, 3. Finally, what we need to do is do a translation. So we do transform.translate. If we're rotating towards another object, and that's being taken care of by the line above, we can pretty much just move forward and expect that we will hit the object that we're looking for. So we'll use vector3.forward, and we'll multiply that by time.delta time, and we'll go ahead and use rotation speed here. It's not really important that we make a new variable for that. And that should be it. So let's go ahead and save this script. And what we need to do is we need something for our cube to rotate to and move to. So I'll make a new object here. We'll put a sphere in the scene. We'll move it a little ways away. And then on our cube, we will drop the follow script. Make sure if you've been following along to turn off the move my object, that kind of thing. It may also be worth it to turn off the camera movement script. It's not really necessary, but I'm going to go ahead and do it. Then go ahead and save. Hit play. And oh, I forgot to assign the toFollow variable. So if we look at if we go to our cube, we look at here, it says toFollow in the bottom right. We'll just drag in the sphere transform, and there we go. That should be it. And hit play, and there you go. You see the let's see, what did we do here? Angle, direction, transform position, rotate, angle, translate, forward. I'm sorry. We should have put transform.forward in here because we want to know the angle between our forward vector, our current forward vector, and the direction. So putting in the position there is not a good idea. Let's try again. There we go. So you'll notice that when you actually get to the sphere here, it starts doing this wild thing where it keeps trying to get closer and closer to the sphere. The problem is that it's never actually going to get where it wants to be because we've coded it in such a way that it's always going to be doing a rotation and it's always going to be doing a translation. Now, one way to fix this would be to check the distance between our cube and our target, and if it's within a reasonable bound, then we can say, let's not, do this operation anymore. So I wasn't planning on doing it, but let's go ahead and do that right now because we'll learn a little bit more, and that'll be good for us. So basically, we want to do a check and update, and checking means if statements. So we'll say if vector3 dot distance. This is a function that takes two vectors as sort of positions and returns the distance between the two vectors. So we'll take the distance between the toFollow transform dot position and our current transform dot position, and we'll say if it's less than some epsilon. So basically we could put in a pretty small number. Actually, we'll just say it's greater than, because that way this will make more sense. So if this distance is greater than, we'll say 1. It doesn't really matter. You can get as close as you want within a reasonable epsilon. And then we'll wrap up the entire thing with curly braces. So that basically says all this code will only execute if this statement here is true. So if our distance is less than 1, we're not going to be running any of this code. That should stop our cube from trying to get so close and then continuing to rotate and translate, etc. So let's save and run again. And we get close and stop. There we go. Now if we want to see that things are really truly working, we can, while it's running, we can go ahead and grab our sphere and we can start pulling it around. And you'll actually see the cube continues to try to follow it. There we go. Got a little bit of a weird edge case where the cube starts rotating occasionally, just like that. That probably has to do with the epsilon we picked. Let's try putting it to 2 instead. Save again. And we'll continue to move this around. Yeah, it looks pretty good. So applications for this, obviously you can think of a lot. AI is one, probably the biggest one because it's pretty common that the characters on your screen are trying to run around and kill the player and that kind of thing. But it's also, you know, one of the best applications of translations and rotations. So once again, we'll take another look at the code here and really kind of look at what we did. So we have an object that we're going to follow, and that's of type transform. We have a rotation speed. And then in the update, we say if the distance between the two positions is greater than 2, then we try to get closer. So we find the direction vector using some vector subtraction. We find the angle between the two vectors, our direction vector and our current transform.forward. Remember, this transform.forward is in local space. So if you think about it, our forward is always sort of changing and getting closer and closer to the direction vector that we found. So this angle is getting smaller and smaller. And then we rotate around the y-axis at whatever angle we found times our time.delta time times the rotation speed. And then finally we transform.translate by moving just forward and again multiplying it by those values. So hopefully that's pretty clear. The nice thing is, if you wanted to, you could create a new function for yourself. We'll call it, I don't know, function rotate to and follow. And while we're here, I'll show you how to pass data into a function. If you're not familiar with that, you just give it a name, say target. Actually, you know what, we'll have it set to the to follow so we don't have to change our code. And then inside here we can take all of our code, copy and paste it in here, and just call the function rotate to and follow and passing in our transform like that. So as your projects get larger and larger, it becomes more and more important to essentially try to cut things up so that when you're looking at your update function, you're not looking at a ton of different code. It's much easier to read, and you have a guarantee that once that function's working, you can kind of ignore it and focus on the other stuff. So that's it for this lesson. Hopefully that can help you out.